Hi students, welcome to Ankush Sir classes. Today's topic is addressing modes in 8085 microprocessor as well as the types of addressing mode, and we will explain in this video out of 5 addressing mode only the first 2 addressing mode. So the next slide shows you a type of addressing mode and then we will go for addressing mode and all. So this is the introduction part, the types of addressing mode. So there are total 5 addressing modes they are given. From upcoming slides, I will explain you one by one in a detail. So first of all, before going to discuss a type of addressing mode, we will learn what exactly the addressing and why we require that addressing and where we use that addressing. So next slide shows you the addressing, definition of addressing. So this is addressing mode slide. So the definitions they are given, it is the various formats of specifying the operands. Now the question will arise in mind, what exactly the operands. So simple way, uh, whenever we are using any instruction in microprocessor to instruct the microprocessor, the instruction is made up of opcode and operand. So here they are given a add C instruction for example, and they are given ADD is a opcode, that is operational code, and the C is a operand. Now here C is one of the register. Onto that register add operation is work. So in a instructions, whenever the operation is operated onto any register data, then that is called as a operand. So here in this instruction add C, the C is a operand and add is a opcode. Now these instructions are nothing but some type of actions the microprocessor will do. So every microprocessor has its own set of instructions to execute a work, to execute a program. Now these all instructions are belong to any one addressing mode. So each of these instruction uses one of the addressing mode. So once again, what is addressing mode? It is the various formats of specifying the operands. Now specifying the operands in slide, they are showing that add C, C is operand. So here I am specifying this C with add opcode. So this is the one way we can specify or represent a operand. So there are total 5 addressing modes in a 8085 microprocessor. So in the next slide we will look one by one a type of addressing mode, as well as in detail we will learn the first 2 addressing modes. Now see, here I will show you the type of addressing mode. Now the fifth one, we will start with the last one. The fifth one is implicit addressing mode. Now the next is a register indirect addressing mode. That is the fourth one. Third one is direct addressing mode. Second one is immediate addressing mode. And the first one is register addressing mode. The sequence is not important. You can write by any ways, any sequence you can follow. But just for explaining purpose, I am taken register addressing mode is the first one and the immediate addressing mode is the second one. So these are the total 5 addressing modes exist in 8085 microprocessor. Now every microprocessor has its own set of instructions and each instruction belongs to any one of the addressing mode. So in 8085 all around 100 instructions are there nearby, so that all instructions are belongs to any one of the addressing mode. So from the next slide, I will show you register addressing mode and immediate addressing mode. So in- the next is register addressing mode. First of all, this is a register addressing mode. Now, whenever how we recognize that the instruction is belongs to register addressing mode, whenever the operation, the executions is done between the two register, then it is called as a addressing register addressing mode. Now for example, here they are given add C. So look at the slide. Here they are given add C. Okay, in the slide they are given add C instruction and move B comma C. Now the meaning of add C is what? Adding a register C with accumulator. So here the add operation is done between the register C and accumulator. So accumulator is nothing but register A and C is one of the register, that is register C and A. So operation is done between register A and register C. So here execution is done between the two registers. So it is a register addressing mode. So instruction is belongs to register addressing mode. The next instruction they are given move B comma C. Now B comma C, in that here they are given, look at the slide, move B comma C. Here move B comma C means moving the content of register C to register B. Whenever we are writing the instruction, a destination comes first and then source. So here the register B is a destination and register C is a source. So here the move the content of register C to B. In microprocessor, yeah, we can say that in 8085 microprocessor, a register uh, moving means actual the data is copying. So here the C register contents are copied to the B register content. Now again this move operation is done between the two registers, that is B and C. So it is belongs to register addressing mode. The another definition of register addressing mode, we can say that when the source operand is provided as a register only, then it is called as a register addressing mode. So in the first example, they are given add C. C is a source operand. So source operand is a register, then it is called as a register addressing mode. So register addressing mode is always of 1 byte instruction. 1 byte means 8 bit. Now in 8085, especially in 12 computer science syllabus, the instructions is whether it is 1 byte, 2 byte, or 3 byte instruction. So this register addressing mode is always of 1 byte instruction. And because it is 1 byte instruction, it requires less memory to execute. So it executed very fastly. So this is a register addressing mode. Now in the next slide, I will show you the diagram of register addressing mode. Yeah, taken one instruction. So here I am showing you the add B instruction is a register addressing mode instruction. Here the B is a source register and this register B is added with the accumulator. So this accumulator contents and register B contents are added one by one. So accumulator is of 8 bit 1 2 3 4 5, 6, 7, 8. So 8 bit means 1 byte. In 8085, accumulator size is always of 8 bit, that is 1 byte. And registers are also 8 bit. So 8 bit plus 8 bit. So here we are taken the addition operation. So here 1 plus 0 is 1. Then second 1 plus second here 0 is again 1. Likewise third 1 plus 0 is 1. Now fourth is 0 plus 1 is 1. And the remaining are all 0. So 0 plus 0, 0 plus 0, 0. So all zeros are there. So my operation over here, I am taken addition B, add B operation. Add B operation is done between the register B and accumulator, and the result is again saved back to the accumulator. So whatever the previous data the accumulator have, it will erase and the new result will place into the accumulator. Now according to this result, a flag, so this is a flag in 8085, a 8 bit is required to represent a flag. In that, in 8085, total 5 flags are there. So sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. So according to this, a flag is set. Now here, whenever I add these two registers, accumulator contains a positive result, and whenever the result is positive, the sign flag remains a reset, that is 0. And whenever the result is negative, this sign flag will turn as a 1. Now here the accumulator does not contain all zeros, so 0 flag is reset. Now the third, fourth, this auxiliary carry flag. Here this auxiliary carry flag means what? Whenever this first, second, third, fourth position data is added with the fourth position data and a carry is generated over here, then only the auxiliary carry flag is set to 1. But here 0 plus 1, only 1. No carry, extra carry generated, and it is not forwarded to the fifth position. That's why auxiliary carry flag remains a 0. Yeah, we can say that it is reset. Likewise, the next is parity flag. Here you can check that parity flag. A parity flag is what? Here 8085 follows even parity. So here the number of ones are 1, 2, 3, 4. So even numbers are there. That's why parity flag is 1 is set over here. So whenever the number of ones are even number, then the parity flag is set. And the next is last one is carry flag. The carry flag is this. So here carry flag carry flag is not generated over here. So by mistakenly it is wrongly printed over here. It should be a 0 and 0 because carry is not generated over here. By mistakenly it is typing as a 1. Here it should be a 0, and here also it is a dash, a 0. Okay, so this is our add B instruction. Now the next is immediate addressing mode. Now the immediate addressing mode is a second addressing mode they are given. So second addressing mode, yeah, we can say that why it is called immediate, because data is appeared immediately after the opcode, then it is called as a immediate addressing mode. Now see, look at the slide. Here they are given, for example, MVIC 05H. Now MVIC is my, actually MVIC 05 is total instruction, but here MVIC is my opcode, that is operational code, and 05 is a 8-bit data. So after the opcode immediately data is available, that's why it is called as a immediate addressing mode. So the meaning of this is move immediate. MV means move and I means immediate. So move immediate 05 data to C register. Already I told you that destination come first and the source is afterwards. So here move immediate data 05 to register C. So This is a immediate addressing mode, and this immediate addressing mode is of 2 byte. So they are given it is of 2 byte instruction. MVIC will consume the first byte and 05 will be the second byte. The next example they are given ADI01. Now what is the meaning of ADI? AD means add and I means immediate. So add immediate 01 data. Now they are not given any register over here. So whenever they are not given any register, it is by default accumulator. So ADI01 is added with the accumulator, and again the result is placed back to the accumulator. So this is also immediate addressing mode, because after the opcode immediately data is appeared, and this also consume a 2 byte instruction. Yeah, it is also a 2 byte instruction. Now in immediate addressing mode, the first byte is always a opcode and the second byte is always a 8-bit data in a hexadecimal notation. So it is a immediate addressing mode. In the next slide I will show you a diagram of immediate addressing mode. The immediate addressing mode instruction, that is ADI01. So here ADI08 is my instruction I am showing you. ADI means add immediate 08 data with the accumulator. So here this is the accumulator. My accumulator contains 0001100, and this is a 2 byte instruction. So here they are given opcode of ADI C6 and a 08 data. So 08 data is a hexadecimal notation. I am converted into the binary notation. So this 0 will represent all these 4 zeros and this 8 will represent 1000. So in 11th standard, yeah, in previously we know that how to convert the hexadecimal notation into binary notation. So ADI, the opcode is C6 and 08 is the data. So whenever I add 08 into accumulator, again the result is placed back to the accumulator. Now look at here, I'm adding this accumulator to this data. So 0 plus 0, again they are given here accumulator. So according to accumulator, the flag is set over here. So they are given here the flag. So just I explained earlier the flags, they are given sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. So this is my ADI08 instructions, and in this they are given this part is before execution and this part is after execution. They are giving. Thank you. Thank you for watching my video. If you like